assure that a simulation is good, we extract the data of the simulation to do a cost analysis. We first extract the frame type of I-beam it uses, which is right here. Then we use this table as a reference for the cross-sectional area of the frame. Over there, right here. Okay, and we know the length of each beam that was given. Then we can calculate the volume. And since we know the density of steel, we can calculate the mass. And we know the price of steel per pound, so we can calculate the cost of each frame. And if we add up the cost of every frame, we get the cost of the bridge, which was a total of $4,736.04. Another data analysis we do is to make sure the safety factor holds for every frame. To do so, we again take every frame of the bridge, find the maximum force that each frame carries, and we calculate the area using this formula, which is right here in the corner. And here is the calculated area okay, and we compare it with the actual area of our selected frames. Oh, sorry. Okay, with the actual area of our selected frames. And if our selected area is larger or equal to our calculated area, it means that the bridge is safe and that the safety factor holds. DJ, take it away.
Hello everybody, so my name is Chijong, and what I'm talking about is that after we analyzed all the data, we built the model scale bridge, and I'm going to give you a summary of what we did. We first determined the objective of the project, in our case, which was to build a wire and truss bridge, which given specifications, and we have to understand what are the conditions, the loading cases, etc., etc. And with those specific requirements, we go and examine the different conditions, the different loading cases, and simulate them in our software, SAP 2000. And with the simulation in place, we analyze the simulation data, like if there's a bridge, a frame that needs better and stronger and thicker cross-sectional area, or is the cross-sectional area of such member too expensive that we have to reduce it, and then we analyze the simulation, improve upon it. And then after that, we reanalyze the cost. Once we get that, we know that our bridge is secure, we reanalyze the cost of what the cost of the safe bridge is, and the safety factor which Carmen shows you. And with that, once we're sure that the safety factor holds and the cost is feasible, we actually prepare the scale model, which you can see there. And with that, we will test the limits of the scale model. Thank you very much.
I have a question.
Okay, sir.
First of all, thank you for your great presentation. And I just want to cut this applause before I ask my question. If you are presenting, please try not to be reading a lot from the book. Just try to present.
Can you tell me which part was in the book?
The other thing, you are not the professor over here, right?
Oh,
if you ask a question, just be respectful to your friend.
Oh, okay.
All right?
Yeah.
So which means when you ask a question related to what they're talking about.
Oh, okay.
All right? It's not your role to give details because you are as well you're a student.
Yeah.
Give advice outside of the class.
Yeah.
All right?
Yes, what was the question?
Yeah. Yeah, I was just asking, why did you choose the scale factor of 1.5 or something?
The reason we use a scale factor of 1.5 is because 1.5 is good enough for a safety factor, which usually we don't just build a bridge once it's safe. We want to make sure that it can hold more weight than it actually holds. And the safety factor gives an extra 50%, the 1.5, right? 1 meaning the actual what it can actually hold, and 5, which means 50%. So it holds 50% more weight in case there's an unusual case like more cars are passing by, or wind factors, etc., etc. Any other question?
No.
Thank you very much.
Yeah, thank you.